here. Basically, one of the things I noticed was that you know, the position of this kind of matters depending on what station you're tuned to. So some of the lower frequency stations, I've turned this all the way up. See that?
She was married at the age of...
And then some of the higher frequency stations, you'll get that. So I have to turn this down a little bit. See that? So a little bit of experimentation there, but you get the general idea. The tubes look cool, and that's kind of why I like it. I think all this stuff in the front end looks really cool, so I keep it all here. I did clump all the wires together and put them through this hole here, and that goes under this thing. It goes underneath there, pops out the hole back here, and then it goes to the filters and then the amplifier here. And so anyway, like I said, you don't need all this stuff in the back, so I'm not even going to go into the details. You can just use an LM386 if you're starting off. And what I like to do is, even here, this is a little LM386 circuit I built with a 9-volt battery. And this is really handy to have around. I use this for all my projects. And this is basically ground, this is ground, and this is high the input. So you can just input your signal here, and this is the volume. And this has a gain of 200, so it'll detect some very weak signals. And you can even use this to test your supply sometimes. If there's any AC writing on it, you'll be able to hear it. Of course, there's a capacitor in here so that you DC couple or AC couple it. But just build one of these. It's just the LM386 and some caps and stuff. Just follow the data sheet and a 9-volt battery, and you'll be able to test out your circuit. Actually, turn this off. Actually, you don't even need, you can just build this part first. Don't have to even worry about this, and you can hook, basically take this, hook the positive and negative across here and here. Make sure you use a resistor like an 8K. This is a 10K pot, so use a 8 kilo ohm resistor from here to 12 volts. If you just short it directly to 12 volts, it probably won't work. At least that's what happened to me. And you'll be able to hear stuff. So you can just test that this works fine. You don't have to worry about the rest of the wiring. And since this thing has a pretty high gain of 200 already, you don't even need to step it into here to give it more gain. You can just hook it up directly to here and here, and that's only 3 connections on here, and then obviously the heater for this. So yeah, it's really handy to have those LM386s around, because you can just test out pieces pretty easily to see if you hear something. But I think the hardest part about getting stuff for this radio is this section here. So I'll have to try and find some stuff, and that's why I'm saying AM might be better to start out with, because it's easier to find these things. You can get them on Amazon or whatever for the AM stuff, where it's normally 365 picofarad or whatever, instead of 8 to 12 picofarad. So for AM, what else? That's pretty much it. I just wanted to put this out there so that people wouldn't be discouraged and would like to maybe try and build their own. This is, with tubes, I think they're really cool. They're actually quite easy, and they really work well for RF, and a lot easier than solid state stuff for me. But the Morgan Regen is a really good one. Basically, with the tube, you can just look up the 12EC8. This is a space charge tube, and you just Google that, and then Google datasheet for 12 VCA datasheet, and you can pull up the datasheet, and then the datasheet on there will tell you the pinout. Of course, you'll have to get a socket. This is a tube socket. You can also get those on Tubes and More or on eBay. And when you look at the datasheet, they'll have the bottom view of the socket and the pinout. And I drew something like this for the pinout, so I know, how to wire it and everything. And yeah, so that's pretty much it. I guess for the audio, what I did for the audio is I put the audio into these op amps. So here I just had my RC, and these are the filters. So 1/2 pi RC gives you your cutoff frequency, and I used 6 stages of op amps to get all the high frequency stuff filtered out, so that I'm not wasting energy. So say it's oscillating at 60 kilohertz and the audio is riding on top of that, I wanted to set the cutoff to 15 kilohertz, so that anything higher than 15 kilohertz was going to get filtered out. And I put like 6 different stages on there, so that just having one filter only gives you 20 dB per decade. So having 6 stages will give you 6 times 20, 120 dB per decade roll off. And if you add these resistors here, basically this is now becomes a non-inverting op amp, and this is R2 and that's R1. Your gain is 1 plus R2 over R1, and so you can increase your gain here. So this is the audio coming in from the tube here, going in there. And the advantage of the op amp, it's high impedance, and this is very high impedance output, right? This can't do much current. So you put it into the op amp. This is also high impedance, and then it's gonna amplify it and act as a buffer as well. So now here, this is low impedance. This is a low impedance output. I can use this to even not quite drive speakers, but I can, this definitely can do some work. So I can do multiple stages of RCs here, and this can now go in with a resistor into an amplifier, my TDA 7294 amplifier. This goes in there. So anyway, I hope that helped. I didn't want to get too much into the audio stuff, but this is kind of a good start, and I might make some videos if people find this helpful for like a crystal radio and the AM regen radios and some of the lessons learned there. Another thing that I wanted to point out too was this is a choke here, 2 microhenry choke. I used a toroid. I just found a little toroid shell, and I took some wire and I actually wrapped the wire myself. And you can probably find these toroids and get the inductance per turn squared on them, and then basically that will allow you to calculate how many turns you need to get the right inductance. So if I need 2 microhenries, I calculated I needed 100 turns to get 2 microhenries out of this core. So that's inductance per turn squared. So you're going to square each turn is going to square your inductance. So 100 turns there. Or you can just take a bobby pin or a piece of ferrite and wrap as many windings as you can. Make it like this thick. It'll be plenty it'll do its job. So anyway, that's it. Hope that helps. Good luck. Let me know if you have any questions.